All right, I figured a good way to finish off lunch, like to come back and talk about animation. That's my favorite thing to do after lunch. I assume it is all of your favorite things too, because that's what we're about to do. It depends is like, it's an answer you've probably heard so many times, and it's like, those two words, you're like, they're so true, like they're really true, but they're also like woefully inadequate to actually answer any of our tech questions. And it's an answer you'll get like in pretty much any time you ask someone like, what kind of technology thing should I use for blank or this other thing? And it is definitely a question you would get if you ask someone, what should I use to animate in my web project? They'd be like, it depends. And you'd be like, ugh. So today I want to dig into what it depends actually means when it comes to web animation. Because we have so many options and so many possible ways to get things done, how do we figure out what the it depends really means? And essentially, what do we do when we're faced with a question like this? Yeah, to answer that question, we need to go into the world, or enter the world, rather, of web animation. I hope you're all prepared. Oh, good. That was more than I expected. All right. This is the world of web animation. Maybe you've seen it before. It's actually technically accurate to the pixel map. That's not really true. But when it comes to web animation, we have so many options to get things done. Years ago, we had like no options or one option, and now we're like, we have so many ways we could possibly get this done. We don't necessarily know offhand which one to use first. So I want to talk about this world today and kind of go through which things are best for which kinds of tasks, how you can use each to like play to their strengths. And we're going to talk about it in the context of like what I like to call the day job context, in the sense that like all of these technologies can do amazing and like super impressive things if you push them to their absolute limits. But when you have like budgets and a timeline and a team to answer to, you want to pick probably the best tool or the most efficient tool for the job. So we're going to talk about it in that context today. And our first stop is going to be Css Island. Have you been there before? It's kind of a cool place. I especially enjoy the icy keyframes. So fun to skate on. I just made that up. I don't know if that's true. Anyways, I want to start with CSS for two reasons. One, because it can often be like the simplest answer to any web animation problem you might have. It can often be like the easiest solution or the one that requires the least effort from you. And I'm kind of a lazy person, and if there's a simple answer to a question, I like the simple answer. So CSS can often be that for web animation. And the things that CSS is best at are things that have well-defined state transitions, like you know where you're starting, and you know where you're going to go, and you can just be like, CSS, please take care of the middle, and it will be like, okay. CSS is very friendly. I don't know if you've noticed. It's really great for loading animations, things that need to loop, things that need to happen over and over, those sorts of things it's really great at. And it's really great for animations that need to happen on events that CSS is aware of, like hover, focus, and all of those things. I think lists are always better with examples, so I have some examples for you too. So CSS is great at things like this, these little hover animations. This is a fancy hover animation because it has a blur. Yeah, simple doesn't necessarily mean like it looks simple. It's like simple under the hood, but the end effect can still be really impressive, which is my favorite kind of effect. When it's like, that looks so complicated, and you're like, it wasn't. That's the best. It's also really great for like loading things into place. Like if you just are loading a page and you're like, hey, stuff, why don't you animate into the place you're going to be? And it's like, okay. CSS is like, got it. Here is your editor of some kind. CSS can be really great at these looping animations. For example, if you wanted to ring a bell to let people know they had messages, or well, like figuratively ring a bell. It's not a real bell, but it animates in this little ringing thing, kind of goes on and on. It loops really well in the real thing, but my video, I didn't do a good job looping the video, but it can loop and do that and just keep repeating over and over and do its thing. Of course, we use CSS a lot for loading animations. You probably don't usually have 8 of them on one screen, but if you wanted to, you could, see? Maybe just pick one. 8 loading things, but it's really great for these sorts of things. And even though all of these examples so far have taken up a very small amount of screen real estate, CSS can take care of big stuff too. It can animate things that take up the entire screen, like this full screen navigation menu. which is pretty cool. Not only that, this one also does it with a little bit of fake 3D. Notice how that text kind of like came from being invisible and in front of us, down backwards into space to being visible and right on the screen. So pretty handy stuff. CSS can do a lot of things like that. Even though this is like using that 3D perspective kind of look, it's still got that one thing in common that all of these examples have in common. There was a very defined place where they started and a very defined place where they ended. Like this one was like, starts out with opacity 0 background, then the pink background goes to opacity of 1. And then our text is like up here and it comes back there, but you know exactly where it's beginning and ending. So some of the advantages of working with CSS are things like this. The fact that you don't need any external library. If you're making a thing on the internet, you're probably already using CSS. I feel like I can't think of many exceptions to that, so you're probably using CSS somewhere, somehow, in some way. And if you are, using it to animate stuff means it's already there, so you can just add some animation to wherever it is. There's no external library needed. You don't have to have any meetings about, like, let's use another third-party thingamabob, or let's add some more things to download, because it's just going to be there. And it's pretty tough to write enough CSS, like keyframes or transitions, to actually bloat your CSS file. I mean, it can be done. Not a challenge I would invite you to try to conquer, but it's pretty tough to do. You get a lot of performance, like freebies, essentially, just by using CSS, which is one of the reasons why I like to turn to it first. Not that you can't get those same performance gains with other technologies, but CSS often just has them built in, and you're like, thanks, CSS. This is why we're friends. Or maybe that's just me, whichever. Keyframes can be reusable. You can write a set, like a chunk of CSS keyframes, and then just keep like throwing them. Well, not literally throwing them, because that would be weird, but pointing that at many objects over and over, keep reusing them without ever having to adjust them or rewrite them. That can be very handy. And you can also really easily adjust the properties or conditions or things that these CSS animations do in a media query, because they're both CSS. And CSS gets along real well with CSS, which is maybe a weird thing to say, but it works. So that's lots of good stuff about CSS. But obviously, if everything about CSS was wonderful, we wouldn't need to visit the other islands. So there are some drawbacks to working with CSS. Most specifically, it has access to a limited set of events, right? Like CSS doesn't know where your mouse is on the screen. It doesn't know if you clicked on a thing. It doesn't know if you made a gesture. And it's not like, that's just not CSS's realm. It's busy doing other CSSing things. So it doesn't know those things offhand. You have to define your animations entirely ahead of time, which is part of why it can be so performant, but there's circumstances where you can't. Like, what if you don't know where this animation is going to end up until you've gotten some input at runtime, until someone makes a gesture or click or some other circumstance happens? CSS is not going to be able to handle that quite as well, and may even be, may not even be able to handle it. You can't currently separate transform properties. So transform properties are like our scale, our rotation, our translation. All of those things you like to animate are all in one property, which is great until you might want to be like, what if I wanted to animate my scale at a different rate than my translation? Oh, I can't, because they're both transforms. And there's an asterisk there because there is some efforts being made to separate these properties out. And right now in Chrome Canary behind a flag, you can separate them out. But if your audience includes anyone who uses things other than Chrome Canary with a flag on, you can't. And I should maybe put a second asterisk there, because CSS variables, CSS custom properties or variables, whatever you want to call them, can change this a little bit. They can give you a little more freedom, but they don't really truly separate them out. So definitely some drawbacks to CSS in the sense that it's kind of, it does what it does really well, but you can hit a wall pretty quickly in what it's not so great at doing. There's one really great way to kind of extend what CSS can do, and that's using it with its friend JavaScript. Because they work together all the time. Why shouldn't they animate together? I can think of no good reason. So a lot of the times when people take this approach is they'll use JavaScript for the logic layer of knowing things that CSS can't know, and then just tell CSS to trigger specific animations at specific times. Be like, okay, now it's time for that transition. Go CSS, and CSS is like, okay, done. And then we can get things that are a little bit more, maybe a little bit more complex, but but still being able to rely on CSS to do most of the motion. So that could be things like this explainer piece for Stripe checkout, where all the actual animation and motion is happening with CSS. And there's some JavaScript basically keeping track of when things should play and when they should leave. All right, play the entrance transition, now the exit, now you go, now you go. And JavaScript is essentially like conducting this animation and keeping track of that sort of higher level logic and then triggering CSS as needed. So it's a best of both worlds kind of thing. We can use it on a smaller scale too, this CSS and JavaScript combination, on things like this is part of Medium, where there's this little icon you can click, and when you click on it, more icons come out for a submenu. And this is the same kind of thing. The motion is handled by CSS, but the actual logic of like listening to that click and then triggering an animation based on the click is handled with JavaScript. So in this case, when you click on this little plus arrow, it's like, doop, here you go. And all of that, the motion is done with CSS. And I made it loop forever and ever so we can watch this for the rest of the afternoon. Just kidding, we won't. There's a better loop we can watch later. So that said, with CSS, the things that it's really, really great at, the things like it is going to totally have your back on, are animated interactions with defined states. If you know where you're going and you know where you're ending, CSS has got you covered. Simple interactive animations. And again, simple doesn't mean like boring or basic. It's just like you can do a lot of really interesting looking effects just by like animating some scale and opacity. You know, these clever combinations or layers of simple effects don't necessarily have to look boring. And it's kind of nice when you can boil these things down to very simple pieces. Their biggest advantage is that you can get some performance gains with very little work, and there's no additional requests, which I've added there again because it's like one of those things that seems so simple, but on some teams it's like the designers aren't allowed to touch the JavaScript. They're only allowed to touch the CSS. So if they animate in CSS, that's fine. There's definitely cases where there's some projects or some teams where you're like, the last thing I can do is convince anyone to like use a whole other third-party library, and they can just get things done in CSS instead. So that's an advantage I think often gets overlooked, that it's like usually just already there. So of course, when we're talking about CSS animation and what it can do and what it can't do, the next question I almost always get is like, okay, CSS is really cool, and it's kind of awesome, and you just told me it's my friend, but how do I know when I might need to start looking at JavaScript? And I'm like, good question. I have an answer for that. Actually, a couple. So I have some rules of thumb of when it's a good idea to move past CSS to JavaScript, even if the things you're doing might be, CSS might be able to kind of cover, but you're like, where's that edge of where I should look to these kind of more elaborate solutions or more JavaScript solutions? One is if you're chaining more than 3 animations together in a sequence, which CSS can totally do, right? If you wanted 3 animations to play in a row, you'd be like, here's animation 1, CSS. And then animation 2 would conveniently be delayed for the same duration as animation 1, so it just happened to play when animation 1 was done, right? And then you could have 3, and then the animation 3, its delay would have to be set to the duration of animation 2 plus the duration of animation 1, and that would work really great and be fine until someone was like, oh, I think it should be just a little faster. Then you're like, okay, change the duration of animation 1, change the delay value on animation 2, change the duration on animation 2, change the delay value on animation 3. You see where this is going. It can get old really fast, and when you have these longer chains, working with JavaScript can save you a lot of overhead in being able to make these edits quickly and easily and in a less fragile kind of way. So you can make those edits and things won't just fall apart. If the animation needs to change dynamically at runtime, if you have to go to a different place depending on different input, or if you don't know how big a thing's going to get until there's certain input when the page actually loads, JavaScript is going to be a little better at handling that. It's going to have just a bit more knowledge of what's going on, essentially, to be able to take care of that dynamic nature. If you need to animate their transform properties separately, most JavaScript libraries or writing your own JavaScript can do that pretty easily, mostly because of the CSS that they boil down to in the end isn't stuck in that specific transform rules. They can use matrix or whatever and do different calculations to more easily separate this stuff out. Basically, they math more so they can separate them out. That's the technical way it works. It's really not. And the last one is when you need things that are more complex easing, whether that's something that has like more complex bouncing or more changes in speed of slowing up and slowing down and speeding up, or if you need like actual physics, then JavaScript is going to be the better choice for what you need to get done. And the main reason is that CSS has one kind of easing it can do. It can do cubic Bezier easing, which is awesome. It can cover a lot of ground, but it can get a little dicey when it comes to actually making physics happen, because that's very different than springs. It's very different from anything that has like calculating values of gravity and friction and all that you can't really do with cubic Beziers. You can fake it, but if that's not good enough, if that's not detailed enough, you might need these more complex kinds of easing to get the job done. So, as you might have guessed, our next stop is going to be JavaScript Island. I think right now we might be near the WebGL mountains. I've seen them outside. Anyways, things that JavaScript can be really great at is more complex animated interactions, things with more moving parts, things that have to hit more areas along the way, all those sorts of things, more complex logic behind when they start, what they do, all of that kind of stuff. If you're trying to go for something that's maybe less of a traditional like UI and more of something that has narrative qualities or is storytelling or is trying to be immersive in some way, JavaScript is going to have these more tools for you to be able to get that done. It's going to be a little bit more efficient at doing these kind of more complicated things. When you have dynamic state transitions, if you have a thing that you're like, all right, button, sometimes you go over there, and sometimes you do this, and sometimes you do that, and it all depends on what happens to you. Like, that's multiple states it can go to, and JavaScript can do a better job at managing those, or at least manage those more efficiently, where you could get it done with CSS, but you might find yourself writing a lot of extra animations and just kind of tying knots of animations around yourself, which I'd prefer not to do. So some examples of these, this is the menu on Stripe.com, where they have a very dynamic set of dynamic animations on their drop-down menus, where their menus are various sizes, both in width and height, have various amounts of content, and it just kind of moves around to, animates their transitions between them, how they appear and how they get from one to the next are very similar, or actually kind of the same, but the end result of how big it's getting and how tall it's getting change for each one. So by using JavaScript to do this, they are better equipped to like, oh, if that first menu suddenly has 2 more items to add or take away 4 items, the JavaScript will be much more able to handle those without completely rewriting things. Or even if they're like, hey, actually support needs a drop down now too, that would be something that would be much easier to add if this was all running with JavaScript, which it pretty much is. So JavaScript is also really great for drag and drop interactions, even like both fancy ones like this or just regular drag and drop interactions. It's like you never think of how many parts there are to drag and drop until you try to make it. And it's also really great at the kind of entrance extra bounces on those modals, how it like bounces in more than once, which is definitely something that's going to take a different easing than our cubic Beziers. So this more complex easing, the drag and drop, being able to, mostly because JavaScript gives you that logic to be able to respond to those different positionings and just do things really quickly based on the drag and drop interaction. So it can be a better choice for those too, or a more efficient choice. Also, if you have multiple objects that need to all respond to the same input, for example, if you were making a 3D lion, in this case, it's a cute little 3D lion on all the parts of his 3D lion body kind of reorient themselves based on your mouse position with the fan because he really wants to cool down. But all the parts of the little cubes that make up his lion self, they're all responding to the mouse position in their own way, but all from that same line of input. So even if you aren't making a cute cube lion, which, I mean, that is a pretty cool thing to do, but even for other things where there's multiple objects moving or reacting to one particular piece of input, JavaScript is going to be more efficient at handling that and keeping track of all of those things. I mean, it's always a bonus if your project has whiskers, but, not everything can be cute lions. JavaScript is also really great for animations that are kind of more like timelines. Like if you imagine them being like mini timelines that play over and over. And it's not that CSS can't do that, it's just that JavaScript has logic that makes it easier, or logic abilities that make it easier to keep track of those and keep them dynamic. For example, in this little portfolio show, there's a whole like kind of phrase of animation that gets played over and over on these multiple parts. So they have this sort of like gobbledygook titles coming in, and then the photo does its thing, and then the paragraph comes in, and that sort of one arc of animation or combination of animation plays over and over with different sources. So by having that kind of timeline, that one phrase in JavaScript, they can kind of point it at these different targets and just have it do its thing again. And these text animations are also a good example of some dynamic animations where it's like, show a bunch of symbols and end up at the letter L, then O. Like those are very dynamic because you don't know where you're going until you actually get there. So those kind of phrases or short timelines are much easier to keep track of in JavaScript and then keep replaying them and reusing them on different things to make things just a little bit more robust. Of course, when we start deciding that we need to use JavaScript, we're like, all right, I have some dynamic animations, or I need to do things that are a bit more immersive or just a little bit more complex than your typical UI animations. So I've decided I do need JavaScript. Then you have to go one level deeper into the it depends and ask yourself, are you going to use vanilla JavaScript or some kind of library? I feel like this metaphor, this is the perfect time of day for this metaphor. Yeah. I'm going to pretend like I don't use dessert metaphors all the time, and I just did it for today. In this case, our vanilla cone, our vanilla JavaScript, would be making our own kind of animations, or our own exactly animations, rather, with Requestanimationframe. And if you're going to be writing your own JavaScript animations, this is the thing you want to use, because it's basically like telling the browser, hey, I'm going to animate a thing. Would it be cool with you that you update this function like before you re-render all this stuff and at the right time so it looks good? And then the browsers also can be very smart with it, like pause your animation when the tab isn't active and things like that, and stop you from draining everyone's battery. It's a good thing for everyone in the end. So if we were going to write our own animation with Requestanimationframe, which we are totally going to do, for example, maybe to move a cat across the screen, it would look something like this. So we would need to name our function, which this one I called moveCat, which is what I name all of my functions. Please hire me to write your production code. It's just move cat over and over. Anyways, we would need to name our function something like move cat. And then this function essentially is going to get called on every frame of the animation, which means we need to tell it what to change on each frame. So we're like, hey, if we want this cat to move across the screen, which is what I've decided it's going to do, we're going to have to change its x value on each frame, right? So it ends up going across. And the idea is we change it fast enough and it looks like it's moving smoothly. So we need to like calculate some new value for it to move to on every frame. So in this case, we're like current value equals your change in value times progress. Basically, math something to come up with a new position. That's what that line is doing. Then we need to tell the cat, hey, go to your new position for this frame. We've decided to add like 4 pixels to your translation, so add that to your translation, please. And the cat's like, OK. Then we attach this function to Requestanimationframe to basically let the browser know, like, do good stuff with this and make sure it renders at the right time and manage all of that stuff. And then, of course, the last line is possibly the most important. We have to call the function we just wrote. I'm sure you've never made that mistake. I mean, I know I've never done that either, but I just figured I'd point it out. So if we take that exact code with just a little bit of additional logic to like stop the cat from moving all the way off the screen and using slightly longer variable names, pop that in CodePen and actually play it, we get this. Pretty impressive. We moved a cat. But, what if we wanted, this is, granted, I use some really long variable names here, so it's a fair amount of code to essentially move a cat from over there to over there. And what if we wanted the cat to go back later? What if we had 20 cats? Or what if we wanted the cat to use some sort of easing besides just linear easing? It's cool because he's in space right now, but if he was on Earth, we would need some sort of ease-in situation. So there's a lot of things that can start piling up and make this more complicated, and you're like, okay, I'll have to write the logic to use a different easing function so we're not just adding 4 every time, and then I'll have to add some condition to be like, if you hit this line, then turn around and go back, or whatever else. And suddenly this starts going from something that was fairly easy to things that are starting to get really complicated, or perhaps too complicated. And those are the kind of places where you want to start looking at a JavaScript animation library. Because doing your own is totally good for a couple one-off ones or just a few here and there. You don't need to get a whole library just for that. But what these libraries are is basically a collection of shortcuts of common tasks you do with animation to save you from having to write them yourself. And when you're doing a lot of it, or even some critical mass of it, that starts being really helpful. So we can look at some JavaScript animation libraries. And you'll notice this sundae also has vanilla ice cream because underneath the hood, pretty much every one of your JavaScript animation libraries is doing Requestanimationframe animations for you. Pretty good metaphor, huh? Not just because I like ice cream. So when it comes to JavaScript animation libraries, there is a huge spectrum of them. We can get anything from just a little bit of a list of essentially some easing equations we could use with our own Requestanimationframe animations, all the way to things that are essentially animation platforms, and we'll cover every possible thing we could want to do with animation. They've got us covered. So it's there's that whole spectrum of them. I think most of the time when you're turning to a JavaScript animation library to get a project done, assuming you've decided you need JavaScript because you have this more complex interactions or complex animations you're making, you're probably more on this end of the things that are more of an animation engine or animation platform. So that's the end that we'll look at. I think it's generally the one that's going to cover more ground for you and really answer those things that you need it to do to make your job easier and more efficient. So the other thing with libraries, besides the fact that there's a whole bunch of different varieties of them, there's also a whole ton of them. Even if we look at just the end that's these more comprehensive animation platforms or animation engines, there's still a lot of them to look at. So how do you decide which one to use? And I realized I could just tell you to use what I use, but that wouldn't be very helpful. I have my favorites, but I think it's more useful to show you how I would actually go about picking which one to use for a project. So if you came to me today and you're like, I have some complex dynamic animations that require JavaScript, please animate this project for me. And I'd be like, okay, cool. Because that's how all my project inquiries go. It's really strange. So if I was starting a brand new thing that I knew was going to need JavaScript animation, here's how I would go about figuring out which one of these animation libraries to use. So the first thing I do is come up with a short list. And I hear 3 is a good number for a short list, so I would try to come up with 3 of them. When I originally put this talk together, I was like, oh, I'll go to some of those JavaScript statistics sites and just pick the top 3 most used animation libraries. Perfect. Except most of those statistics sites do not have an animation category, so no luck there. I'm like, all right, I'll have to actually, think a little bit and come up with my short list. So I came up with a short list based on the stuff I've seen people use in various experiments and projects. So the first one on my list of 3 was the GreenSock Animation Engine, or GSAP, or whatever various variation of the name you want to call them. Because they've been around for a while, I see people use them a lot on CodePen. They seem to get a lot done. A lot of the SVG animations I see tend to be done with GreenSock, so I'm like, that's going on my short list. We're going to check this one out, see if I like it too. The next one I put on my list is Velocity. For many of the same reasons. Velocity's been around for a while. I've seen people use it on projects, not so much on CodePen and stuff, but it's around. People seem to use it. It's been around for a while, so I'm like, that looks like a good stable one to check out. And then the third one to round out my list, I would look at Anime.js, which is a newer one. Definitely hasn't been around as long as Velocity or GreenSock, but I've noticed that Mary Lou uses a lot on her code drops experiments, all those fun things that she does on the code drops site. And I'm like, if it's good enough for her to do that stuff, I bet it's probably good enough for me too. I bet I can use it and do cool things. So yeah, short of statistics, I just went by what I saw a lot of to make my short list, and hey, that works. So once I've got these 3, I probably want to look at their similarities and differences to figure out, what pros or cons would there be to using one particular one, or what would I be giving up using one versus the other, all of those smart decision-making things. But before we get into the differences, I really want to show you what they all have in common, because to me, that's the most interesting part of all of these. And the interesting thing is that they all work in a very similar way. They have a very similar pattern to their base functionality, because essentially, under the hood, what they're really doing for you is taking a thing and animating it. And they all do that in a really similar way. So, for example, if we wanted to animate a thing with GreenSock, for example, animating a box, GreenSock uses tweenmax as its actual that's the thing you invoke, because 2 names are better than 1, I guess. So we could be like, hey, tweenmax, take this box, change the opacity to 0.5 and move it 800 units over 1 second, and use this power to easing. And that would move this box over 800 pixels or units, depending on what units we're using, and then make it fade out a little bit over 1 second. And that's pretty cool. So if we wanted to do that same animation, that same amazing animation, I'm sure you're all like, wow, I've never seen such beautiful animation code. Fade a box out and move it over. Yeah. Anyways, if we wanted to do that same awesome animation with Velocity, it would look like this. We'd be like, hey, Velocity, take this box, change its opacity to half of what it was, move it 800 pixels over, take 1 second, because 1,000 milliseconds is the same as 1 second, and, ease and quad that stuff. Kind of looks pretty similar, right? Of course, we have to check out Anime. If we wanted to use Anime to do this exact same amazing animation, we'd be like, hey, Anime, take this box, change the opacity to half of what it is, move it 800 pixels over 1,000 milliseconds, which is the same as a second, and use this easing of easing quad. And the biggest difference between all of these is the fact that GreenSock calls easing quad power to ease in, and the other 2 call it easing quad. Really, the rest of it is is it easing or ease? It's the same exact bits of information, just with little different syntax around it. So I'd like to show this to be to show you that, if you've learned one animation engine, you're not going to start over if you have to use another one the next time, or if you have to learn a new one. You're already partway up the learning curve once you've got one of them down. All right, so now let's look at the differences, because that's probably more exciting, especially besides just making a box half its opacity. So if I was going to compare the differences, I would make a comparison table, because that's what you do to compare things. First thing I'd probably look at is the size of these files. And when I last checked all of these, GreenSock had a variety of different variations of it that you could use. You don't have to use just one version. There's different kind of components or bits you can use for different things. You can use them all or just one, and depending on whether you use one or just all of them, it'll be somewhere between 7 and 29K when it's gzipped. So you're like, okay, I like options, that's cool. Velocity has just one version of itself, and that's around 14.4 kilobytes gzipped. So you're like, okay, see, this is going all right. Anime, on the other hand, is a little bit different, where it also has one version of itself, and it's just like 4.7 kilobytes when gzipped. So already we're seeing a lot of differences in the file sizes. You're like, oh, that's interesting. What else might be different? I'd probably also look at what kind of browser support these had. GreenSock can make things work all the way back to IE8. That's a pretty old browser. Velocity can also go back to IE8, and Anime can only go back to IE10. So if you're like super on top of things, even though you just ate lunch, you might remember that IE10 is the lowest version of IE that supports Requestanimationframe, which means Velocity and GreenSock are doing something to provide a fallback for Requestanimationframe in browsers that don't support it. So maybe that functionality is part of the reason why their file size is bigger. You're like, huh, getting somewhere. I like that I've made this into some like detective thing. I'm like, and they aren't doing it. Anyways. I would also look at where I could get some help. I'm sure none of you do this, but sometimes I wait to the last minute to get stuff done. And I've noticed that when you're working on a thing the night before a deadline, things break and you don't know what to do and you're really stressed out. I mean, I'm sure you've never done that either. But if I was going to be in that position or in any position where I wasn't sure what to do, I'd want to know, like, where can I find help for these libraries? So GreenSock has a pretty active set of forums. They have documentation, and those seem to be places where people help each other out a lot around this code. Velocity's also been around a while, so it has this documentation and also seems to come up a lot on Stack Overflow, a lot of questions and answers, so that's pretty helpful. Anime is a little newer, so it really only has its documentation. Though its documentation, I have to admit, is a little easier to read than the other two for the most part, but doesn't seem to be a huge community around it yet, so it might be a little bit, or just there's one place to go for assistance. Another thing I would look at is special features. So for example, GreenSock has some special features for Draw SVG and Morph SVG. If I was SVGing, I might want to use one of these, because SVGing is a thing, in case you were wondering. Velocity can be a drop-in replacement for jQuery, which if you're working on a team that uses jQuery right now and you want them to use something else, but you don't want it to be awful and terrible for them, that could be great. Like that could be like, yes, that is what I need. Boxes checked. And Anime is, of course, very, very lightweight, so that's pretty helpful as well. One last thing I might want to look at is their licensing, which GreenSock has some features that cost money, and they have a very specific commercial license for if you're like selling products that have it in it. Both Velocity and Anime use the MIT license, so different licensing and the way you can use them and what you might have to pay for it. The one thing I don't have in this chart that I would also look at would be performance. But I've noticed that just about every animation library or website or engine's website that you go to, they all say they're the most performant. So you're like, well, you can't all be the most performant, because if everything is performant, nothing is performant? I'm not sure that saying works for performance. But anyways, they can't all be the most performant. So I think it's really useful to do a performance test with your short list of libraries on the kind of animations you'll actually be doing. Because for example, if you're doing a lot of fades and scales versus doing a whole lot of SVG animation, you might get very different results from these different animation engines, and it's really best to know what it's going to be like on your own stuff. So I would check that out as well. But pretty interesting to see the differences and similarities to make that decision of what's going to work best for your project. So to summarize our pros and cons of JavaScript, our little trip into JavaScript Island, JavaScript is super awesome at, spoiling it already. JavaScript is super awesome at really complex animation, things that have a lot of moving parts going to a lot of different places, dynamic states as well, anything that's going to be more immersive in storytelling, where you're creating more of like a world or a story and not so much just your basic interface. Not that there's anything wrong with your basic interface. I appreciate both kinds of things. The biggest pro from working with JavaScript is that there's so many options to get things done. If you don't like one animation library, there's like 50 others for you to choose from, so you're not tied to one if you don't want to be. And it has the magical ability of being able to animate DOM elements, SVG elements, canvas elements. Is there anything JavaScript can't do? Didn't think so. All right, so one last stop before we leave JavaScript Island. I want to talk a little bit about React. And not because I think you should all be using React or that it's the best thing ever or whatever else. There's enough Medium articles that will tell you that, so I don't need to tell you that. Oh, that was a joke. I don't really believe those Medium articles. But React is a very popular framework, and it's one of the frameworks that seems to be the least straightforward in knowing how you should animate things in it. Many of the other frameworks are like, this is how we do it, and React is like, here's 50 billion ways we do it, and you're like, ugh. So, making sense of the 50 billion or so ways, it's a very exact number. There's two things I wanted to point out about animating in React. And the first is that you can use the things you use on not React on React. So we can use familiar things. For example, if you had some CSS like this, which is some CSS that looks for a thing with a class of drop, and then it applies two animations to it to make it fall down like a raindrop and then fade out at the bottom. It's for raindrops. That's why it's for the class of drop. My naming conventions are amazing, I know. If that CSS existed somewhere in our project, somewhere on the same page that a React component was rendered out that had this class in it on anything, then it would actually apply that animation to it. So for example, this is a little SVG icon that's part of a React component, and it's like, oh hey, there's some CSS making me move, so I'll move. And if that component wasn't there, CSS would not care, it wouldn't break, there'd be no errors, it would just be like, I guess there's nothing to drip. And that would be that. So this can be really useful when you need to do things like animate stuff in place like this. You don't need to go through like, giant hoops to add in all other things to animate specifically for React. You could actually just use some CSS to make these icons have a bit of motion. You can also use React with JavaScript animation libraries, and not necessarily ones that are like a specific React flavor. You can make React work with like just the, I don't know, the regular version of the library? I'm not sure what the unreact version would be. Really should have thought of that before I said those words. Anyways, essentially what you would need to do is any React component that is actually going to render out to the DOM, render out some HTML elements to the DOM, is going to have a render function, and you can write some HTML-ish stuff in that render function. So if in that render function we were making this amazing component, which is a list of boxes in a container, very complex. I'm sure you do this all the time. And we saved a reference to that container of just like that little bit that's just like ref, C equals a scene. We're saving a reference to the scene. We can use that reference again later when we know that stuff is in the actual DOM. Because the HTML in these render functions, once that component is on the page, they will be in the actual DOM, and then we can use them. And like, well, not use them exactly, but we know they're there. So with that reference saved, we can do things on the component lifecycle events like component did mount, like, hey, use that reference, and now point tween max at that reference of the container of boxes we just found. And then we can use tween max just like we did before. We're doing almost the same thing. No, we're making the opacity 0, or going it from 0 to 1, so we don't just fade it out. But we can do that same thing, pointing tween max at that reference and having it animate things. And in this particular case, we get a bunch of flipping boxes. Yep. So for small amounts of animation, when you're just doing one or two things and they're not necessarily dependent on a whole like chain of state logic, you can use these things we've already been using for non-React stuff quite easily without having to go through go through this giant step just to get one or two things moving. Of course, there are more React-y ways to animate in React. And I've used a bunch of them, but I wanted to give you a short list of the two of them that I've used in past projects that didn't make me hate everything. So the first one is Transition Group Plus. There's a lot of things that have almost the same name in React, so it's really hard to say the names right. But Transition Group Plus is this really great component that handles both exit and entrance animations like together as one thing. So you can remove things and have another thing enter in its place, and do that in a way that is like very nicely neat and logical and kind of packaged together. And I love this one because oftentimes when you remove a thing, you want something else to come back, and this handles them both really nicely. Works on not squares too, but this demo is really fun. The second one is React Motion, which is really great if you need springs, because React Motion is springs. If you need springs and you're doing React Motion is your thing. So React Motion makes things behave like springs, gives them some sort of tension and other factors, and then just kind of sets them free into the world, and they're very, very springy and lovely. If you need springs, that's great. Springs, though, are pretty awesome, but they're not really like the most all-purpose animation. Like there's definitely things that you might want to do that springs can't handle well. Like if you want to chain things together, or you want to have a thing happen when the spring is done, springs tend to visually look done before they are done, which can make things be a little bit weird. But if you need springs, React Motion is your friend. And one other thing, which makes 3 out of 2 things I'll mention about React, is React has recently changed stuff over, kind of the way they render things to be fiber, which is a different way of their rendering stuff, which will affect the way animation works. So if you've had issues with animating in React in the past, fiber might make those, kind of smooth those out and make those easier. And Lynn Clark has the best introduction to fiber because it has cartoons, and she explains exactly how it works and why it is good for things. So that's pretty great. All right. We've got one more island to cover. That's SVG Island. I think this is my favorite island. Well, I mean, I guess it's landscape. It just has rocks. But I mean, SVG always seems so simple, but it's so powerful. More specifically, my favorite thing about SVG is the fact that this is an SVG. This is that same SVG. So that is this, is that, is this. They're the same thing, but one is like the visual side of it, and the other is those exact same things described with math. Oops, wrong way. Yeah, math, there you go. This is those exact same objects, but described with like numbers and points as opposed to being the ones that you see on screen, but they are the same ones that we see on the other screen. So just like that one had a cloud and drops, this version has a cloud and drops. And they're actual objects in our SVG that we can like reach into and animate and have like real actual things, which is wonderful. So things that SVG are super great at. Animated illustrations or icons, which I guess you could argue that icons are like small illustrations, but most people I know who make icons would not agree with that. So animated illustrations or animated icons. Infographics and data viz, things that like need objects. You can make an object in your SVG that represents data and it's like a tangible thing. Oh, it's so amazing. Anything that you need to like have be scaled fluidly. We talked a little bit about how CSS could change animations based on media query, but SVGs are just like, what size do you want me to be? Don't care. Just tell me a size. I will make that size happen, and it will be beautiful and crisp and vectory, because that's how they roll. So these advantages of SVG mean it makes it really great for things like these bustle. Oh crap, I just forgot the word of what these are. Of these little quizzes that they do, these kind of flowcharts. This is one big SVG, just one giant SVG. I mean, giant because it's on this giant screen. It could also be very tiny if my screen was tinier, but that would be kind of mean to all of you in the back. And this one SVG, they can animate around it essentially by moving the view box like a camera to show you different parts of it, and you can like answer questions, and it can move some more, and it can do all this stuff, and they're really just like moving around and animating parts inside one SVG. And the fact that it's one SVG means they can use it as like a full screen thing, they could use it as a half screen thing or a quarter screen thing, and it would just work in every one of those situations because they just make it smaller or bigger. So SVG is great for these kinds of things, both because it is so fluid and you can kind of like have this container that contains these objects you're interacting with. And that can be really useful in cases like this. SVG is also really great for animating logos. Like literally, if you were ever in a meeting and someone's like, I think we might animate the logo, before they finish that sentence, just be like, SVG. Will not make you look weird. Your coworkers will not think you've had too much coffee or, I don't know, hit your head. But it will totally be the right answer because most times you want your logo to be nice and crisp, and there's generally a vector version, and SVG is going to be your best pal for making those animations happen. This is one by Chris Gannon, who if you like SVG animation, you totally are probably familiar with his stuff. SVG is also great for shape animations. Anytime you want one shape to become another shape or like a group of shapes become another thing, things like this. This is another Chris Gannon one. And I feel like this one brings up a really important question for our industry. Like, why not the pizza menu? I like pizza better than hamburgers, so how come no one asked me? Anyways, SVG can be really great for onboarding animations as well, especially when these tend to be like animated illustrations. This one is part of the onboarding experience for StoryTrail, and they essentially have a series of animated SVG animations that they just transition in between to take care of all the different slides, and each one of these is a different SVG doing its thing. SVG is also really great anytime you want things that look like they're straight lines and like, rigid objects to be not rigid objects, to be like flowy and gooey and like, all sorts of things like that. And they just like, you thought that was a line, but it's not. Oh. And then dramatic wipes of flame-shaped things and all that kind of stuff. So anything morphy and mushy, SVG is like, I got this. I'm so good at being morphy and mushy. I don't know if it actually uses those words, but I think it should. So when it comes to deciding you want to use SVG because you want that beautifully flexible, vectory, scalable, mushy, malleable stuff, we need to go one level deeper into it depends again, because SVG can be animated in 3 different ways. You thought we were like getting, nope. So SVG can be animated with SMILE or SMIL, however you prefer to say this acronym. But SMILE has some issues. It is not supported in IE or Edge. Probably never will be, I'm sorry to tell you. And it's being deprecated in Chrome. So it's like there right now, but may not be later, which kind of makes me think that SMILE might not be the most future-proof way to animate SVG. If you already know it and you use it, cool. If you were thinking of learning it, maybe use one of the other 2. CSS can animate SVG, which is like, come on, CSS, our old friend from like forever ago, can animate SVG? It's really growing up. What can't CSS do? Almost nothing. We can use transitions and keyframes on SVG elements, both like the SVG image itself and the things inside it, those actual inner objects. We can apply CSS to that. There is a limited number of properties CSS has access to, but that's not CSS's fault. SVG only reveals so many to it. That list of properties will get longer with SVG 2, which is why in some versions of Chrome you can do things with CSS that you can't do in Firefox, and eventually those will all be at parity there. The one main problem is that transforms on SVG child elements, that's the key part there, are not supported in IE or Edge, which means if you wanted to translate a thing or scale a thing, an SVG child element with CSS, it would not play in IE or Edge, which makes CSS a kind of okay way to animate SVG. Like if you had an icon and you animated it with CSS, an SVG icon, you animated it with CSS, and it just didn't animate in IE or Edge, that may not be a big deal, right? You could just get all progressive enhancement with it and be like, all right, if you have a browser that handles the animation, you see the motion, otherwise you see a static one, and the icon means the same either way. So it can be okay for those sorts of things. But if you have critical information in that motion, and you're like, ooh, that would be not as great. So there's definitely cases where CSS can work pretty well, especially for those smaller bits of animation that is more of an enhancement than critical content. But for things that are very critical, our third option of JavaScript is going to be your best option for SVG, because it can literally do everything that SMILE can do. It can do morphing, it can do motion along a path. Depending on the ease of getting those things done will depend on which JavaScript tools you use to do it, but it can do all of those things. And the browser support is also much better than CSS. There are some inconsistencies in browser support, which is what a lot of those animation libraries help us take care of, but at least it actually works, unlike CSS, which isn't supported there. So for any more complex or critical animations in SVG, JavaScript is your best bet, because it can do all the things, and it has a wider range of browser support. But the main thing I wanted to point out with all of these is that SVG has really, really good support. This is the can I use for SVG. That's like so much green, even Opera Mini. So that's never green. It's true. So all of these browsers support SVG. They can display SVGs, and SVGs are their friends. So the thing that might limit the browser support of your SVG animation is not SVG itself. It's which one of those 3 things you chose to animate it with, because all 3 of them have different browser sort of gotchas that you could run into. So it's not SVG. It's the thing you're animating it with. And as we move forward with SVG 2 and browsers keep modernizing and adding more things, I think we'll be more on par. But right now, there are some differences between the 3. SVG is super visual, so if you prefer to make things in a visual way, there are some tools to actually take After Effects compositions and export them as SVGs that you can play on the web. Amazing. There is a library that was called Body Movement and recently got renamed to Lottie Web, which lets you do things like these were all some After Effects animations by Al Boardman that they ran through Lottie Web and made them be SVG animations. But for some reason, I made this not a video, so you just have to believe me that they're animations. Imagine that they're moving. Oh, wait. Just kidding. Lottie, in its more, non-web state or grander state, the Lottie tool itself, can also take After Effects compositions and adapt them for Android, iOS, React Native, and get into all those various kinds of platforms. So it's pretty powerful for getting SVG animations from After Effects into all these various places. If you're curious about how Lottie works, there's a site called Lottie Files, which actually is a gallery of existing Lottie files. You can kind of poke around and look at the source code and see how they come out of After Effects and how they go into these different platforms without having to make them yourself. It's kind of nice that way. So SVG. It's really great. Illustrations, infographics, icons, anything that needs shape morphing, motion along a path. One day CSS will be able to do motion along a path, but it can't yet, so SVG is your friend. And its biggest advantage is just how fluidly responsive it is by nature and the tiny file sizes you can get. When those objects are all described with numbers and math, those file sizes can be tiny, and that's kind of magically amazing. You can have all this stuff happening, and you're like, and it's like 5K, yay. So we have one last stop on Web Animation Island, or no, world, sorry, of the islands. Oh, I can't even get my maps right. And that is the stuff that they're all sitting in, performance, which I hear is kind of a big deal. So we could spend like hours and hours and hours talking about performance, but I'm going to look at it just in more specifically, the kind of web animation area. So you may have heard that there are 4 properties and/or 2 properties, depending on how you want to count them, that browsers can animate most efficiently, and you should always use these for the most performant animations. And people usually either list that as transforms or scale, position, rotation with transforms plus opacity. So 2, 4, same difference, as they say. And if you're wondering why it is that these 4 or these 2 can be animated so much more performantly than other CSS properties, because gosh, we have a lot more than 4, I'll give you the short version of why. So browsers go through a series of steps when they actually render new visual content to like our viewport window. And they're like, hey, something changed. I need to render new things to this screen. It goes through a certain series of steps. So the first thing I'm going to look at is look at the styles that are affected. Like, which things need to change? Are you just changing the color of this button? Are you changing the layout of the whole page? Is every object different? Is one of them different? All those questions browsers wrestle with in their sleep. I don't know. Do they dream? Who knows? Anyways, after it's figured out which things are affected, it needs to figure out what kind of layout changes will need to be made. Are things going to get wider? Are they going to get taller? Will that affect their siblings? Will that affect their children, their parents? All of that stuff. What layout changes will happen? Then the browser actually goes and paints those pixels to the browser window, which I like to imagine a little gnome with a paint palette just being like, red pixels? Yes, blue pixels. That's not what's really happening. My version of a browser is so much more entertaining, though. And then as a last step, the browser will go and put all of those pixels it's painted to the screen in the various layers that they need to be in. We often think of our web pages as being very flat, but there are layers to them. There's some pretty fancy dev tools to see like the 3D stack of layers. So everything goes in those layers in the last part. And the thing is, these things have to happen in order, and the most expensive one is paint. So if you change a property that affects both style, layout, that affects style, it has to go through layout, then paint, and then composite. If you affect a property that only affects the paint step, it has to do paint and then composite. So if we change a property that can happen only on the composite layer, on that last step, then we skip the most expensive one, which is paint, and things can be more performant, which is essentially what happens with our transforms and opacity. They can take place entirely on that composite step, and that gives us that performance boost. So if you're wondering what kinds of steps other CSS properties hit, there's this handy site that Paul Lewis made called Css Triggers, which has a list of every CSS property, tells you which steps it hits, and for each individual browser as well. It can be pretty informative. There's a couple of ways to investigate and figure out if you're getting that hardware acceleration that you want, that performant animation. To show you a couple of ways to find out without digging too deeply into DevTools, I made this set of cube animations, or these squares. The top one, the orange one, is animated by changing the margin, and the blue one, or the aqua one, is animated by changing the transform, or the translation of the transform property, which means they look pretty much the same when they start playing. They're like, okay, they're kind of similar, they're doing the same thing. But if we go and turn on paint flashing, which is going to make a green rectangle around every time we have to repaint to the screen, you'll see that orange one is being repainted on every frame of the animation. That's the opposite of hardware acceleration. But there's no frame around the aqua one, and that means it's not being painted, it's not hitting the paint step, it's all happening on the composite layer. So we're like, cool, you're hardware accelerated, good job, aqua cube, aqua square. I should have given them better names. So that's in Chrome. And Firefox can turn on paint flashing as well. But Firefox also has another tool within their DevTools that can help us out with kind of investigating whether we've got that hardware accelerated animation and what to do about it if we don't. So this is their Animations tab. And if you have hardware accelerated animations, it'll give you this little lightning bolt. Be like, good job, hardware acceleration. But if for some reason the animation you have playing can't be hardware accelerated, it gives you this little underline like, uh-oh. And then it gives you a tooltip to tell you why it might not be hardware accelerated and some clue as to what you might be able to do to get it to be hardware accelerated. So this is a really handy one if you're like using transforms or opacity and you're like, this should be hardware accelerated, why isn't it? Firefox can give you some hints, which I think is super, super helpful because I don't know about you, but I don't know every detail of the inner working of browser rendering, so sometimes I'm confused as to why my stuff isn't hardware accelerated, and this really, really helps. So let's look at our three friends of CSS, JavaScript, and SVG, our three islands, and how they stack up when it comes to performance. So CSS, as we talked about a bit before, is declarative. Like the entire animation is known ahead of time. It's in your CSS. It's already there. It's like it's just already there, and then it plays, essentially. Whether you're doing keyframes or transitions, that's essentially what happens. So that makes it declarative and means it can be often a little bit more performant because it's like that, at least by default. One other thing to note about CSS transforms or CSS animations in general, transitions or animations, they're not affected by the main JavaScript thread. So if your JavaScript is doing some really hard thinking, and you're animating with JavaScript, the hard thinking could affect your animation. But if your JavaScript is thinking really hard, CSS is just like, wee, doing its spinner thing. It's not affected by that main thread. So that's one of the reasons why CSS often gets used for loading animations, because it's kind of that two separated things. JavaScript, like we saw when we were doing our Requestanimationframe animation, the browser only really knew what was happening on that one current frame. It didn't know what already happened. It didn't know what's coming next, just like change this much per frame. So that means we need to do a little bit more work to get some of these performance things that might come for free with CSS, or that we might not have to think about. So even if we are animating, like doing Requestanimationframe animations with transforms and opacity, we still have to tell that JavaScript animation to be hardware accelerated. We can do that with like a null 3D transform and that kind of thing. And most JavaScript animation libraries also do things under the hood to make sure you're getting that hardware accelerated performance wherever you can. So sometimes people like to say that like CSS is always more performant than JavaScript, but it's just never that simple, right? It's like you can write really unperformant CSS and you can write really performant JavaScript. It's really more about like what you're doing with the tools, not which one you're using. So what about SVG? SVG, sadly, well, the child elements of SVG, so SVG DOM elements or child nodes, cannot be hardware accelerated in most browsers. As far as I know right now, Firefox is the only one that does it. So if you're animating the inside objects of SVG and you're wondering why you're not getting hardware acceleration and you're in a browser that's not Firefox, it's because it doesn't happen there. All of the browsers have various like kind of feature requests or bug reports on this, so you can vote them up if you want to see that happen. But the nice thing is even without this hardware acceleration, we can still get pretty good performance with SVG. The parts where you notice that lack of hardware acceleration tends to be when you have a lot of objects. And I mean like data viz quantity of objects, like thousands of objects. If you're trying to animate like 1,000 SVG objects, you're definitely going to see a performance hit because you can't hardware accelerate that. Which is why many really complex data visualizations are done in Canvas, because Canvas can be hardware accelerated, and it's also just pixels. So the other place you might notice this is on like less capable phones that have and mobile devices that just don't have that kind of like processing power. In that case, the lack of hardware acceleration rather can show as well. But in most cases, you still get pretty decent performance because SVGs are just so tiny. So that concludes our tour of the world of web animation. I hope our tour has helped so that next time you run into this question, you'll have a better idea of how to answer it. You'll like have the exact answer. Yeah, you're gonna know 100% what to do. And if you like this idea of interface animation and doing it on the web, I wrote a book that talks more about the design side of all of this, less about the technical things. So if you're looking to do animation good, as I like to say, that book covers it. I also have a newsletter that Jeffrey mentioned. If you need someone to remind you how cool animation is every week, I can be that person for you. And I'm always happy to talk about this on Twitter. So thanks so much.